Today we're going to talk about gas volume relationships at any condition, not just STP, but any conditions. To do this, we're going to start off talking about Avogadro's hypothesis. Equal volumes of gases at the same temperature and pressure have equal number of molecules. This would mean that 2 liters of helium would have the same number of particles as 2 liters of oxygen. So from the Avogadro's hypothesis, doing research with different gases at the same volumes, to come up with Avogadro's law, which is V1 over N1 equals V2 over N2. What Avogadro's law says is that if we have a ratio of moles is equal to a ratio of volume. So this can make stoichiometry from liters to liters of a gas, from one type of gas to another, very simple. So here we have an equation, C3H8, propane, combusting in oxygen produces CO2 and water. We can use Avogadro's hypothesis, which actually is Avogadro's law, to compare any of the gases, the liters of any of the gases in the problem. But we can only, of course, compare gases because liquids and solids do not take up the whole volume of the container. So to start out with, like any stoichiometry, we're going to write down our given 4.25 liters of C3H8. Okay, then if I need to relate C3H8 to oxygen, so I'm going to use my equation. There is 1 C3H8. Normally, I would put 1 mole of C3H8 on the bottom. But because of Avogadro's law saying the directly proportional between a volume and a moles, instead of saying 1 mole equals C3H8, I can simply say 1 liter equals C3H8. And hence, the liters will cancel out. Then I'm going to oxygen. We normally would put 5 moles of oxygen on top, but we can put 5 liters of oxygen on top. So we get a proportion of what the moles were in regular stoichiometry. For here, gas stoichiometry is now liters, thanks to Avogadro's law. So to solve this, I'm going to take 4.25 times 5, which leaves us with 2.25 liters. Putting that into significant figures, we need 3. With 21.3 liters of oxygen would be the answer. Okay, let's try another problem. Using the same equation, what volume of carbon dioxide are produced from 1.55 liters of oxygen reacting with excess C3H8? Just like in stoichiometry, we don't have to worry about the excess. That's just telling us it's there and it's going to react. So we're going to put down our given 1.55 liters of oxygen. Then we're going to go up and look at the ratio of oxygen. So it's 5 liters of oxygen. We're going towards CO2, 3. So instead of 3 moles, 3 liters of CO2. And we're ready to find our answer. 1.55 times 3 divided by 5, which gives you 0.93. But we're going to have to add a 0 on the end of that to keep numbers sig figs. CO2. So liter to liter stoichiometry. And notice I didn't even mention the conditions in this problem. It could be at any temperature, it could be at any pressure, as long as it's not extreme temperatures or pressures where the gases are not going to behave ideally. It doesn't have to just be at STP, because throughout the problem, the pressure and the temperature are going to be held constant. So all we have to do is worry about the liter to liter ratio.